Hello everyone, I'm going to talk about JUnit testing. So to kind of start off here, just a brief explanation of what JUnit is. JUnit is a unit testing framework used inside of Java. You kind of think of it as like an add-on. And the reason why it's an add-on is JUnit is open source. Programs such as NetBeans can utilize its suite of testing products, which can result in an effective way to test your code outputs against matrices developed for each case. JUnit tests can be run automatically and provide immediate feedback, which we'll kind of talk about in my demo. I'll kind of show a brief explanation and just demo of how JUnit works. And you'll see that the feedback is instantaneous. Think of JUnit as a Java object and can be imported in using the org.junit package. And the way that this works is the way I'm going to demonstrate it is using the assertion function, which does use a overloaded constructor using an @test annotation. So just right here, and I'll show this actually in NetBeans shortly, but just quickly, here's a sample code. My function is actually called calc distance 2 points. And we'll see that we actually call that here down below, but I define out my variables. So in this case I have 4 different variables. Your program actually would input in each of these values based on user input or whatnot, but in this case we're just going to hard code it in based on our matrices. And matrix are just unit tests that outline each different type of unit test, and you can test for that. We create a new instance of the math control, and then we pass in, or we create a expected result. So in this case, based on my test matrices, I know my final outcome is going to be this value, and so what I'm going to do is I'm going to test it. So in this case, I'm creating a new variable called result, and I'm going to create an instance of my calc distance 2 point, and I'm going to pass in a parameter of each one of these variables that I've called. And then finally, I'm going to call the asserts equal function, and I'm going to pass in my expected results. I'm going to pass in my results, and it's going to do a compare. And we can actually put a precision on our decimal point. So if I didn't want to go to this level of decimal points, I could do this much lower down. So it's just a way to kind of do that. A little bit about the JUnit assert equals function. As I just said, we pass in 3 different values and it can do a compare. And if it's success, we'll see below here I'll actually get a green check mark. If it's a fail, like I can see in these other examples, it will tell me my expected value was 0 because I didn't put any in, but it actually ran the calculations and this is what it got. So you can see that's just what a success message looks like, and this is what a failure looks like. Just kind of further in the code, just here's what it looks like, just kind of more spelled out. And then finally, there's a lot of assertion functions. I just use the equal one. There's actually quite a few, and I've given you a URL here where you can go to, and it kind of outlines each of those. There's way too many to talk about here in this presentation, but you can play around with that and just use different things to do compares, to use static text, things like that. So I'm going to just jump over into NetBeans real fast. I've got up here, this is my what I call my math control. This is what I used in 261. I actually have 3 different calculation type functions. The one that I was kind of highlighting is this calc distance 2 points. I'm actually checking for error messages, so I do a quick if statement, and this is based on my test matrices that I'm looking to capture an error. If it captures an error, it's going to return a -1. Otherwise, it's going to go ahead and run the equation and return the value back. So in NetBeans, there's a quick and easy way to convert this into a JUnit. If I just come up here under Tools, and I can click on this Create Update Tests, that's going to pop up the kind of the form builder, if you will, or package builder for our test cases. And I've left this as the default, and that's just kind of how it works. So if I jump over into my test package here, you can see here it's called mathcontroltest.java. It actually creates this for you. So for example, this top one here is just kind of the default. I didn't change anything on it. It's going to show just zeros, and it's actually going to have a fail built into that. And so for the one I wanted to work on here, I've actually gone ahead and put in my values, and I've actually called out each of my test cases. So in the first case here, here's my test 1. I've inputted my values, and here's what I've expected, and here's what I want with my exert equals. Next, I've done a test 2. In this case, I do want it to fail, so I've provided just all the same values. Obviously, you can't calculate the distance between 2 points if it's all the same values. So I've returned back a -1, and with that, I know my test case is going to work. Test 3 and test 4, just kind of testing the ranges. I've used negative numbers, and I've used large numbers, and I've provided the expected results on each of those. So if I want to run this, if I come over here and I right-click on my test case, I can come in here and run file. And as you can see here down the bottom, I can see it's actually running, and it'll pop up momentarily here. There we go. It's gone through all the tests. So you can see here my test passed 25%. The reason being is I had 4 test cases. I really only filled out one of them, and you can see they all passed. If I wanted some more information on each of those, I can just hit that down arrow. It's going to just provide that information. Provides pretty good feedback. I can see here, you know, this is what my expected was. Here's what actually was calculated. And this is kind of an easy and quick way to create a suite of test cases. You don't have to just test one function. You can test multiple functions. You can pass in all kinds of different values, and just simply running that will factor through, go through each one of them, test it. Is it good? Is it not good? Okay, it is good. It gives the green check mark. Otherwise, it gives you an error. You can go back and fix the problems in your function and until the point where that's working, and you'll get that green check mark. So it's a great way to error check, fault check, see where kind of errors are, but it's also a good way to go through unit testing and just make sure the function is working as expected. So that is a quick rundown on JUnit. Feel free to ask any questions. I'm going to go ahead and post this on the community board. Thanks, everybody.